In the second example on objects which are connected together, instead of them being connected by a rope or a string, these two objects are just in direct contact with each other, and there's no friction acting in this example either. And we would, if we wanted to work out the resultant acceleration of these two blocks being pushed by 16 newtons, we would just apply Newton's second law as we did for the previous example. So applying Newton's second law here means that we're going to use F equals m times A, but on the full system. Okay, so it's almost like ignoring the fact that you've got two blocks and it's just one block of mass 8 kilograms. So we'll go through the working for that just now. Okay, so by applying Newton's second law, we're able to show that the acceleration of the 8 kilograms here would be 2 meters per second squared. Okay, so there's no friction acting, so it's just the 16 newtons for the unbalanced force. The full system is 8 kilograms for the two blocks together, and that produces an acceleration of 2 meters per second squared. So we're going to now look at the forces acting, or force acting on the 5 kilogram block. From the first part of the problem here, we treated the full system together, and one of the reasons that the arrow is shown here, that's not the way you would normally draw a force acting on an object. You'd normally have it coming from the arrow would originate from the object itself, so it would be acting to the right. But what's been implied here is that the thing's not been pulled along using tension. It's actually been pushed from the left, from behind the 3 kilogram block. So it means that there's a force of 16 newtons being applied to the system here. You would still normally draw that just with the arrow coming out to the right of it, but it's trying to imply that the 16 newtons is getting applied to the 3 kilogram block, or at the 3 kilogram block end of the system. What the 16 newtons does, of course, is it pulls the full system along, and that's what we've worked out here. It produces this acceleration. But within that, and this is what we're now going to do when we're breaking it down into the two component parts, if the 3 kilogram block experiences this 16 newton force, then in order to move the 5 kilogram block, what happens is the 3 kilogram block then pushes onto the 5. So the 3 kilogram block will exert a force on the 5 kilogram block, right? And we'll just draw that in the same way as what is shown here. So you've got this contact force. So the 3 kilogram block is going to push the 5 kilogram block to the right. Again, normally if you were making a free body diagram, you'd have that arrow coming from the 5 kilogram block to the right and originating from the object and moving that way. But just because it's this contact force, this type of force, which has been produced by the objects being in contact with each other, I'm just going to draw it like that. But by Newton's third law again, it means that you'll have a reaction force, and the 3 kilogram block will experience a force to the left, right? And those two forces will be equal and opposite. So 3 kilogram block exerts a force on the 5 kilo block, 5 kilogram block exerts a force back on the 3 kilogram block, and that's a Newton pair of forces. Okay, so action and reaction forces. So what this means is that the only force acting on the 5 kilogram block is this force that's been exerted on it by the 3 kilo block. Okay, so that is the force that we're trying to calculate. Okay, so we would then apply Newton's second law just to the 5 kilogram block, and we'll just have a look at the working and what that shows us then. Okay, so quick look at the calculation there. What that's shown us there is that the force acting on the 5 kilogram block is given by F equals m times A. We're just using the 5 kilograms, so remember what we've done is we've just separated out that part of the system and just looking at the force involved in that object, and that gives us a force of 10 newtons. Okay, so the 3 kilogram block exerts a force of 10 newtons on the 5 kilogram block. But just to finish off the analysis, that would also mean that within the two parts of the system here, you'll have a reaction force, okay, on the 3 kilogram block, and it's going to push it to the left. Right, and that force then would be your reaction force, so that's also going to be 10 newtons. Now this is, again, just to point out, it's a wee bit of an unusual way to draw the diagram, because normally we'd have that red arrow going that way, and the black arrow here would be pointing to the right. From again, it was just to emphasise that that something or someone is pushing the 3 kilogram block from the left, from behind it. Okay, but that'll do for now for the diagram. So we'll just accept that you've got 16 newtons going to the right, 10 newtons going to the left from the 5 kilogram block, and that means that you've got an unbalanced force acting on the 3 kilo block. So again, just to apply Newton's second law, just to finish off the analysis. So we've got an unbalanced force this time. So if we were trying to just show that we get the same acceleration from what we can see happening to the 3 kilo block. So we've got an unbalanced force of 16 take away 10 is equal to the mass is 3 kilograms. We know the acceleration is 2 meters per second squared, but we can just show that here. So that's 6 newtons for the unbalanced force, and you can see that that will then give us an acceleration of 2 meters per second squared. Okay, so that finishes the analysis of what's happening. So like we did in the first problem, we start off with the full system and apply Newton's second law to the entire system, and then break it down into its component parts in order to work out what we're trying to essentially work out here is this contact force, the force that the 3 kilogram block was pushing onto the 5 kilo block. Okay, but remember that also then produces the reaction force back on the 3 kilogram block with the same size of force. Okay, so hopefully that gives you a complete picture of what's happening when you have a force which is pushing two objects which are in direct contact with each other.